Welcome to this comprehensive tutorial for beginners on extending the functionality of existing classes in C#. C# offers several powerful ways to enhance existing classes, promoting code reuse and maintainability without altering original source code. We'll explore inheritance, extension methods, and partial classes, providing clear explanations, code examples, and helpful tips. Let's begin our journey by understanding inheritance, a cornerstone of object-oriented programming in C#. Inheritance enables you to create a new class, known as a derived or child class, from an existing class, referred to as the base or parent class. The derived class automatically inherits the properties and methods of its base class, establishing a clear hierarchical relationship. A significant benefit of inheritance is code reusability, as common functionalities can be defined once in the base class and then reused across multiple derived classes. It also provides excellent extensibility, allowing derived classes to add new functionalities without requiring any modifications to the original base class. Furthermore, inheritance helps organize related classes into a logical and intuitive hierarchical structure, improving overall code clarity and management. Let's look at a practical example. We'll define an animal as our base class and a dog as a derived class. Our animal base class will include a name, property, and an eat method representing common animal behaviors. The dog derived class will inherit these members and then add its own unique behavior, a bark method. When we instantiate a dog object, it can seamlessly access both its specific bark method and the inherited name, property, and eat functionality from the animal class. It's important to remember that C# supports single inheritance, meaning a class can inherit from only one base class at a time. Derived classes have access to public and protected members of the parent class, but private members remain inaccessible, ensuring proper encapsulation. Constructors are not inherited directly, but you can explicitly call the base class constructor from the derived class using the base keyword. Method overriding is a powerful feature that allows a derived class to provide its own specific implementation of a method already defined in its base class. This is achieved by marking the base class method with the virtual keyword and the derived class method with the override keyword. Finally, a key point: classes declared as sealed cannot be inherited from, effectively preventing any further extension through inheritance. Now, let's move on to extension methods, a remarkably flexible way to add new functionality to existing types without altering their original source code. Extension methods allow you to introduce new methods to classes, interfaces, or structs, even those from third-party libraries or the .NET framework, without direct modification. They are implemented as static methods within a static class, which is a crucial aspect of their definition. The defining characteristic is the this keyword preceding the first parameter, which explicitly specifies the type being extended. A major benefit is the ability to extend external types, such as those from third-party libraries or the core .NET framework, without needing to modify their original code. This approach significantly improves code readability and reusability by making code more expressive and fluent. Let's illustrate with an example: an extension method designed to count words within a string. The word count method is defined within a static class and takes this string str as its first parameter, indicating it extends the string type. You can then call word count directly on any string object, as if it were an instance method of the string itself, simplifying usage. A key point to remember is that extension methods are resolved at compile time, not during runtime. Crucially, an extension method will not be called if an instance method with the exact same signature already exists on the extended type. The instance method takes precedence. Extension methods cannot access private members of the extended type, thereby maintaining the type's encapsulation and internal integrity. While incredibly useful, it's important to use extension methods judiciously, as their overuse can sometimes lead to less intuitive or harder to debug code design. Finally, let's explore partial classes, a unique C# feature for splitting class definitions across multiple physical files. Partial classes allow you to divide the definition of a single class, struct, or interface into several distinct physical files within your project. The C# compiler then intelligently combines all these fragmented parts into a single, unified class definition at compile time. The partial keyword is absolutely essential. It must be used to declare each segment of a partial class. All parts of a partial class must share the exact same name and reside within the same namespace and assembly for the compiler to correctly combine them. This feature is excellent for promoting separation of concerns, for instance, by separating auto-generated UI design code from custom business logic. It also greatly facilitates collaboration, as multiple developers can work on different parts of the same class simultaneously without conflicts. Maintainability significantly improves by allowing large, complex classes to be broken down into smaller, more organized, and easily manageable parts. Consider an employee class, where its definition is split into two files, employee.cs and employeedetails.cs. One file, employee.cs, might define core properties such as first name and last name for the employee. The other file, employeedetails.cs, could then contain methods such as getFullName, which operates on these properties. When instantiated, both properties and methods from these separate files are seamlessly accessible from a single employee object, demonstrating their unified nature. Partial classes are particularly common in scenarios involving auto-generated code, such as Windows Forms and ASP.NET applications, where tools generate part of the class. All partial class parts must maintain the same accessibility level, whether public, private, or protected, to ensure consistency. If any part of the class is declared as abstract or sealed, the entire combined class is considered abstract or sealed. In summary, inheritance, extension methods, and partial classes are indispensable tools for extending C# functionality effectively. Inheritance establishes hierarchical relationships, promoting robust code reuse and flexible extensibility. Extension methods allow you to seamlessly add new behaviors to existing types without ever modifying their original source code. Partial classes provide a structured way to split class definitions across multiple files, enhancing organization and facilitating team collaboration. Mastering these fundamental concepts will significantly enhance your ability to write clean, maintainable, and highly scalable C# code. Thank you for joining this tutorial. We encourage you to practice these techniques to solidify your understanding and further your C# development skills.